Assalamualaikum warahmatullahi wabarakatuh. Today we would like to explain about the analytical investigation of calcium carbonate contained in antacid tablet. Now, I will introduce our team member. First, Nur Zafira binti Nur Zakwan. Second, Shasha Shafia binti Khairuddin. Third, Nurina Huda binti Ahmad Syafiq. Fourth, Nur Alfa Alia binti Muhammad Fazli. And last, Nurul Syakirin binti Ahmad Nordin. Here are the list of the content that we're going to talk about in this video.
Now I will explain about the first part of the video, which is the introduction. Back titration is where the concentration of an analyte is determined by reacting it with a known amount of excess reagent. The remaining excess reagent is then titrated with another second reagent. The second reaction of the titration results show how much of the excess reagent was used in the first titration. So by that information, we can calculate the concentration of an original analyte. A back titration is used when the molar concentration of an excess reactant is known, but the need exists to determine the strength or concentration of an analyte.
Since calcium carbonate salt is insoluble, back titration, a quantitative analysis, is used to determine the concentration of calcium carbonate in an antacid tablet. Antacid contains calcium carbonate that neutralizes excess hydrochloric acid in stomach to relieve indigestion and heartburn. To perform this back titration, there are two reactions that are actually involved. The first reaction is between calcium carbonate and hydrochloric acid that is added in excess. And then the second reaction is between hydrochloric acid and sodium hydroxide. For the first reaction, the concentration of calcium carbonate is unknown, which is calcium carbonate is the analyte, and then hydrochloric acid that is added in excess its concentration is known. And then the remaining hydrochloric acid from this first reaction, or we call as the unused hydrochloric acid from this first reaction, is used to react with sodium hydroxide in the second reaction. The main purpose for the second reaction is carried out is to determine the amount of hydrochloric acid or the amount of hydrochloric acid that is reacted with sodium hydroxide, or we call as the amount of hydrochloric acid that is used in the second reaction. By constructing a balance equation between hydrochloric acid and sodium hydroxide reaction, and by using the given amount of sodium hydroxide, we can determine the amount of hydrochloric acid reacted with sodium hydroxide in this second reaction. And then we can calculate the amount of hydrochloric acid that is actually reacted in the first reaction. By using the formula, amount of hydrochloric acid reacted is equals to amount of initial hydrochloric acid is subtracted by excess hydrochloric acid, where the answer is obtained from the first step in the second reaction. And then next, we can calculate the amount of calcium carbonate and the mass of calcium carbonate that is reacted in the first reaction. By constructing a balance equation between hydrochloric acid and calcium carbonate, and by obtaining the amount of hydrochloric acid that is reacted, so we can gain the amount of calcium carbonate reacted in the first reaction. And the final step is then we can finally calculate the percentage of calcium carbonate that contained in an antacid tablet.
I will explain the methodology of back titration between calcium carbonate and hydrochloric acid. Is employed in the analysis of antacid tablet. Antacid tablets often contain calcium carbonate as the ingredients to neutralize excess stomach acid. However, determining the exact amount of calcium carbonate in the tablet can be challenging due to variations in tablet composition and the presence of other ingredients. So to analyze the calcium carbonate content in an antacid tablet using back titration is step 1 is excess acid reaction. A known mass of the antacid tablet crushed and dissolved in excess hydrochloric acid. It crushed into a fine powder to ensure it dissolves completely in the reaction mixture. The calcium carbonate in the tablet reacts with the excess hydrochloric acid, forming calcium chloride, carbon dioxide. Next is to ensure complete reaction. The mixture was stirred and shaken to ensure complete reaction between the analyte and the excess reagent. Next step is to neutralization the standard base. After ensuring complete reaction, Beck titrated the excess hydrochloric acid with a standard solution of sodium hydroxide. The sodium hydroxide reacts with the excess hydrochloric acid until the solution reaches the endpoint, typically indicated by a color change from pink to colorless, using a pH indicator like phenolphthalein. Next, for the calculation, the amount of HCl that reacted with the NaOH solution calculated based on the volume and concentration of sodium hydroxide used. Then, stoichiometry used to determine the amount of HCl that initially reacted with the calcium carbonate in the tablet. So, last step is calcium carbonate content. Knowing the mass of the tablet used and the moles of calcium carbonate reacted, the percentage of calcium carbonate in the tablet calculated. These methods allow for the determination of the calcium carbonate content in the antacid tablet, providing valuable information for quality control and dosage recommendation.
Now, I'm going to explain how to determine the amount of insoluble salt by using back titration. Here is an example of the situation in which a student was asked to determine the mass in gram of calcium carbonate present in a 0.125 gram sample of chalk. The student placed the chalk in 250 ml conical flask and added 50 ml of 0.200 mHCl using a pipette. The excess HCl was titrated with 0.250 of NaOH. The average NaOH titrate was 32.12 ml. Calculate the mass of calcium carbonate in gram present in the chalk sample. To determine the mass of calcium carbonate, there are two steps that we need to do. For the first step, we need to determine the amount of the HCl in excess from the titration result. Before the calculation, we need to write the equation of titration, which is HCl will react with NaOH to produce NaCl and H2O. Then we need to calculate the mole of NaOH that reacted in the titration by using the formula molar mass times volume, and we will get the number of mole NaOH is equal to 8.03 times 10 power of negative 3 mole. After that, we use the balanced chemical equation to determine the mole of HCl, which is equal to 8.03 times 10 power negative 3 mole, and this will be the amount of the excess HCl that was added to the chalk. For the step 2, we need to find the total mole of HCl that originally added to the chalk, which is 0.010 mole, and then calculate the mole of the HCl that reacted with calcium carbonate in the chalk by using the formula that have been shown in the slide. And we will get 1.97 times 10 power of negative 3 mole. After that, we must write the equation to identify if the equation is valid or not. The chemical equation is calcium carbonate reacting with 2 mole of HCl will produce calcium chloride, carbon dioxide, and water. From the balanced equation, we can identify the number of mole of calcium carbonate in the chalk, which is 9.85 times 10 power of negative 4 mole. And with this information, we can calculate the mass of the calcium carbonate in the chalk, which is 0.099 gram.
I will be explaining about the conclusion of our video presentation. In Pharmaceutical Research and Development Laboratory, the back titration method for analyzing the calcium carbonate content in antacid tablets plays an important role in evaluating the efficacy and stability of different formulations. By accurately determining the amount of calcium carbonate in antacid tablets, we can assess the tablet's ability to neutralize stomach acid effectively. This analytical approach enables pharmaceutical companies to optimize the creation of antacid tablets, ensuring consistent and reliable relief for individuals with acid-related digestive issues.
That's all from us. Thank you.